So we've been kind of talking about this like combined ground intake and rotating arm design. So I guess the biggest benefits of this are you can directly change the variability, like the angle of your flywheel, and it favors heavily to a vertical flywheel, which is something we've also kind of settled on doing, similar to the super nerds. And then kind of down here is this was before the Saturday meeting that we had made this kind of weird indexing system. But the whole idea is that the intake spins up into the indexer over here, and then this indexer motor and these two sets of rollers, they're separated. So one travels with this moving arm, and then the other one stays stationary down here. And they're each individually powered by like brushed motors. And these intake rollers bring the node up to here. And then when the arm is in like a loading position, I guess, we would outtake from the intake into the indexing mechanism over here. And then we have a third motor on this indexing arm to load it into the flywheel and shoot when we're ready. And this would allow us to shoot from various points on the field. And it also allows us to combine the mechanisms together into an arm trap mechanism or arm amp mechanism. So it's the same arm, it just rotates up and it kind of just slam dunks it in the amp. And that allows for like really consistent amp cycles if we need to cycle on the amp, and then just overall consistency in terms of positioning. And we did notice that like we'll have a decently long chain run over here to drive this whole arm, and the arm will get kind of heavy. So we'll have to do a lot of stuff with belt or the chain tensioning and making sure that everything is in order so that it doesn't like break or bend. Another idea that we kind of had on Saturday was taking the unqualified Quokka's design for the upper plate arm and then having that just be fed directly by this indexing mechanism so that we don't have to worry about like figuring out new geometries. And then taking this mechanism, I've kind of factored in the trap mechanism into this. And so originally we had a trap mechanism that would, like on the first robot for Team 1, I had CAD'd a trap mechanism that sat all the way back on the robot. But in this case, our trap mechanism would sit slightly outside of our like drive base, but still inside of our bumpers because of the intake protrusion. And then its maximum extension would be up here where it would be able to load directly in the trap. And the idea for this, like the trap scoring mechanism, is that it stays as simple as possible. It only needs one roller and a back plate. That way it can just kind of suck the note in and then spit it out once it's at the trap. And then for the climber, this arm, by the way, is 18 inches long from the pivot to the edge, and then the roller is a little bit offset from that. And then the robot kind of hangs a few inches from the bottom of the chain. I think right now I have it set to 4 inches, but we can always fiddle with that. Yeah, that's 4 inches. And then we can always just kind of fiddle with that with our climber mechanism. And I know I brought up a new climber mechanism kind of last minute, which is I think it's called the zebra climb, but it uses like a boat hook mechanism to, it's basically like a measuring tape on steroids. So it extends up and pulls down with the same mechanism, and it combines all of that into one package. It is a bit more like expensive than a winch mechanism, and it would require us to package in space on the sides of our robot for that. But even the Rembrandts 4481 have done some pretty interesting testing, and it looks pretty promising. So, yeah.
I have one question about the flywheel.
Yeah.
The one with the flywheel arm. Can we make it so that the ambient state of the flywheel, like without moving the arm, scores in the speaker?
Yeah, so that's this pose, and I think we could probably go a little lower and still fit in the wheels. there's definitely space because we're trying to stay below our like extension limit of, so it's 28 inches to the bottom of the chain, but you always want to stay a few inches below that because there will be field variability and like things will happen between matches. So 26 inches is like the design tolerance I've set. And to shoot into the amp, I guess this would just require, or into the speaker, we would just need to do some testing to see where we can set our resting angle.
We've done like the similar kind of idea in Team 2, and what we've gotten from you have a different geometry that should have it angled enough that it will hit the speaker. I have to adapt it to all of this, but the idea is there. I think it just it involves angling the flywheel relative to the arm. So right now the flywheel is at a right angle to the arm, but ours will be in a different angle if we were going to do that.
Yeah, sounds good. The main thing was that if we could, make a whole cycle without scoring an arm, without moving the arm, that just makes it more reliable.
If the arm fails for some reason, or we don't, we don't get it, or if it gets damaged, then we don't
exactly
want to use it. We can run it without it.
Still score even if the arm is flopping.
Mm-hmm.
Also, you got to post this in the CAD channel, man. What's
the inspiration? Have you seen an RI3D team do something similar? An Open Alliance? Or have you guys listened to this idea?
So this idea is kind of inspired by the team with the weird bumpers that I was talking about. I can't remember their team number, but they had a pivoting arm and a ground intake that had a similar setup like this. Let me find it real quick. But yeah, they're like pivoting their arm, and it's kind of just like a combination of the Quokkas and the Spectrum robot. So it's like taking bits and pieces from everywhere.
So if we're comparing this and Spectrum has like a much more kind of shooter that's, I guess, further to the front of the robot. That it's, I think if I read it, tilts like 0 to 55 degrees or something. So it's a little bit different than this, for sure.
Well, I mean like the ground intake part from Spectrum and then the arm part from the Quokkas. I think it's 2582. They have like a...
Oh, that's Panther.
Yeah, Panther bots.
Yeah, we know this. Are you guys concerned about how the note is going to be transferred from the single ground intake into the indexer? How it's going to bend like that?
I feel like, yeah, that's one of the things I was like worried about. I feel like the note is flexible, but if we'd have to have like kind of a smoother bend, I feel. And it's like there've been a lot of like really tight bends that I've seen, and like people have bent the note a good bit, but I think it just becomes like a software problem after that. Like make sure that the arm is all the way down and not moving before
the current iteration of the intake should make it so that that angle is much less steep than what it looks like right now. And the if we're gonna go with what I said with the Team 2's like designed to make it rest at speaker shooting position, we should be the angle to enter the whole shooter mechanism should be much less steep than it is right now. We'll have to work on that, right? So little things like that.
Here, I have the Panther bots thing actually pulled up. Let me just share that. It's basically like the same idea that we had, but they've already like catted it out and chalked up the idea. And
you can see they don't have a compound angle though from the ground intake to the shooter. It looks like it's all just one angle.
Yeah.
So
And I kind of think that's what Samuel was getting at, is like with this, you just shoot right up into the speaker.
But this one looks like they feed it into their shooter backwards, or is it just the small rollers at the top are the actual shooting?
The top row looks like Coulson's. I think that they're the shooter, right?
Yeah, the Coulsons at the top are the shooter for sure. But I think the bigger wheels at the bottom are just to give it more of a variable range, like for the note to come in.
Yeah, that's kind of exactly what Les was saying and what I was trying to show, is that I think at this angle, maybe they calculated so that if they're right up against the speaker, then this is the way to shoot into that, or right up against the whatever's at the bottom, that trapezoid at the bottom, then this is how they score up.
I think that's actually I think this is actually a better mechanism than what we had catted up right now. So, yeah. But the idea came from here, basically.
Well, you don't have much catted except for a sketch, so
Yeah, it's just the sketch.
about than your stuff, that's why I was kind of asking about inspiration. You want to make sure that you're finding inspiration and then staying in tune to that inspiration to see how their stuff is developing. It's another team, so you can learn lessons with it instead of waiting. So,
Why is there a bumper like that?
So they're basically using their bumper as a funnel so that it kind of the note can fit under there, and then it gets rid of the side skirts problem.
I see.
We
the
just
one with CG is they'd rather have their bumper be lower for CG purposes than have all their bumper be raised.
Yeah, they want to keep keep their bumper low, but still have the under bumper intake part. I think that's the only reason they're doing that.
Interesting.
Pretty much.
Yeah, I'm okay with sacrificing CG. Bumper. Cool. So this is a good discussion, guys. I appreciate everyone throwing in there. Do we have some other people that want to talk about things? Maybe code stuff?
I can comment slightly on that. So programming wise, well, actually, I guess I should give an update first. So yesterday at Lamar, we made quite a bit of progress. The current state of the code is that we have our practice swerve all built in, everything, all the software on the electronics is all good to go. And the teleop code for the swerve and autonomous code for the swerve mostly works. We've tested them both at Lamar, and from what I've seen, the code base runs properly on the robot, and it's able to follow instructions given that the robot is mechanically and electrically sound. As of what we're currently working on, I believe Kyle is working on things regarding robot telemetry, getting more feedback from all the sensors and getting more data back from the robot. And I think he's also working on ways to simulate some of how the robot will actually work, so that we can put some ideas into practice and put some mechanisms into practice. And also in terms of what we're doing next, I think there's either two things we could do regarding programming, I would say. One thing, I think Andy was also suggesting this yesterday at Lamar, is we'll probably try programming out some of the subsystems, just pre-programming some of the subsystems, so that when everything is built and ready to go, we'll have some code to start off that we can modify slightly according to the actual build parameters of the subsystems and ready to test. And also regarding some vision things, I believe we do have time for that this year. So I think that's also another thing that some of the programming team could start looking at, is using things like the April tags to update like robot odometry and things like that. And how that could be useful. And also doing some like automation things for drivers. I think that could be quite useful to make matches run smoother and improving the efficiency of cycles. And if anyone would like to add anything or have any comments on that.
Lamar needs to have programming. Really need to have some sawmill. I know you can handle some things. You need to kind of get somebody trained up. Last year. Since that robot's complete and we want to keep it complete, and hopefully we'll get some driver practice on it as well.
Okay.
So kind of me, and let's get somebody up to speed on programming at Lamar. So that stuff. I think we're gonna have 2 rev practices. So the new rev module, you need to treat them very carefully as kind of the final robot, but then the ones that Westside has right now as a current swerve, those are probably going to be our test modules for a while, and those can have lots of practice and just get a lot of miles, a lot of experimentation on them, since that's where most of the programmers are. But yeah, we need a few more programmers, at least one more at Lamar would be really helpful, and then Westside needs to get some other programmers where they can build and test their code on the robots you guys have. I know we have a few people that are kind of there, but they need to be their own computer, downloading code, and then being productive. And if they're not, then I think you guys should move them to some other sub-team and not programming. Make sense?
So I kind of wanted to expand on what exactly I'm doing, because I mean, Adrian touched on it, but basically, I'm basically trying to figure out how to get, I mean, of course I'm working on telemetry in general, but I'm trying to figure out how to get Advantage Kit, which is related to Advantage Scope, which is one of the new things they have. At least I think it's pretty new. That basically I'm able to, it's kind of different from normal telemetry in the fact that it tries to log basically every single input and output, basically, more than we have in the past, at least. And it's designed to, and it's supposed to be able to run a full like physics simulation of the thing, which I feel like that can also be partially useful for like getting programmers to work on something, like to be able to learn if they have a simulation that they can go off of instead of having to actually always have the robot. So, I mean, I'm not sure how much to show. Yeah, I mean, it's, yeah, I mean, I don't know what else to say.
That's a good update.
Yeah.
Glad to hear that you guys are making a lot of progress. I mean, this is, I said this on Saturday, but I'll restate it for everybody. We are way further along than we were last year in programming. So it's really good to see customers have a working swerve module that drives straight, and now they're doing things like autonomous and other things beyond just basic driving. So we just need to keep making progress, clean it up, start adding subsystems, and start adding vision, path planning, like all sorts of things that will be useful once we get the robot in a better state. So it's good, but we need to train our programmers as well. So I know Kyle and Adrian have it, but I don't know how many other programmers have got their system set up. So if you really want to program, make sure your computer's set up, and then you get some time to actually load code on the robot, because that's going to be the way you show that you're ready to do the next step. Greg, go ahead.
No, we talked about this, I think, like either the Sunday after kickoff or even before that. All the senior who has been on the team for more than a year should have some other person they're training constantly. Some other person that's like an understudy, right?
Yeah, I agree. All seniors need to be with somebody that they're helping and working with. So that goes for all schools. Let's try to keep handing the baton over to the new generation so they know how to handle it. Any other commentary? We have a hard cutoff at 8 o'clock, so we got less than 10 minutes. If somebody wants to another item, go ahead.
Okay, so you mentioned that you need coders. So, I learned Java, well, I more or less, and I'm in school, and then I'm also trying to convince one of my friends who's like really good at coding to join. So, with the two of us, that would be two. So we can help with that if he joins. But
Yeah, just make sure you're on the code channel. Ask questions about getting your stuff set up, and once you're downloading code from your own personal laptop, then you're good to go. So that's kind of the goal for all the programmers, is to be able to compile the code and download it from their system and make some changes, and then from there we'll assign each programmer some tasks to work on. Cool. We do need to divide more tasks and that kind of responsibility. So I know Lamar is pretty heavy on the ground intake and testing the ground intake. Eventually, I think we might hand off some of the flywheel shooting stuff to Lamar as well. We'll likely bring a wooden something to practice shots on at Lamar. We could make something similar at Westside. Um, I really want to encourage Westside to focus on the drivetrain and get it to a point where we can get things built that are going to be hopefully very finalized, and then we start moving the practice swerve with all those finalized drivetrain components and start adding, ground intake, start adding all the systems and build up. And then we might eventually start, build two versions of this if we have enough time. So, and Sid, you're kind of in charge and trying to put all these things together in one cohesive CAD so we can start thinking out stuff that's going to conflict. So kind of think about the master plan of what the CAD's going to look like as the drivetrain and the ground intake people are working together.
Sounds good. And I think one of the things we were going to test at Westside this week, we brought some acrylic to laser cut. And I think we have some wheels lying around that we can use to kind of see how the intake works with a swerve drive that we have just with us.
Yeah, I don't want to waste too much time on prototyping a ground intake until we're close to like the stuff that's actually going to mount to the final drivetrain. So I'd be more interested in cutting drivetrain rails if you guys think you have it right and it's been checked. Cutting those rails and modifying the chassis you're currently using to make it drive.
The only question is the dimensions, the final dimensions. So maybe a little early. Yeah. I mean, you got the 27 by 27 right now, so it's a go by.
Yeah, I mean, I think we're going to be pretty close to whatever Spectrum and a lot of these other teams are doing. So, run the dimensions by everybody and ask for a final check, and all the mentors will look at it and will think about it, and all the students will think about it. And let's just say, yes, the dimensions are set, and then we just need to work on all the interconnections, the gussets.
Yeah. Actually, the Panther bots looks pretty good too. Just very, very parallel. So that's good.
We know those guys. They're only like about less than 2 hours away from Houston, I think, over in Lufkin. So very easy team to work with, and we can always reach out to them and ask questions if we can't understand something. So if that's the direction we're going, we should learn from it, and we should probably do a little bit of searching to see if there's anybody else going on the same direction and try to learn from that as well. Because some of these teams are way ahead of us on prototyping, and it's best that we learn lessons from that early you start making the same mistakes. Cool. Well, I appreciate everyone coming out, and we'll try to upload a video if you didn't get it all on our YouTube. We'll watch it again.
Yeah. For open alliance, I need like